Okay, folks, so I wanted to show you this other website, WTFamps.com, Wauwatosa Tube Factory is what it's called. They have a lot of good resources here too. And what I wanted to talk to you about is something called input and output impedance. Now, if you think about it, in this world, there's nothing that's for free. If you want to take your device and plug it into a device, if you think about it, you are going to lose some signal. Like in an ideal world, we wouldn't lose any signal. But what I want to do is give you a tool to think about how to compensate for that signal loss and actually calculate what that signal loss is. And the way that we do that is with something called impedance. Okay, we could think of our circuits. All of our circuits is pretty much we have a signal, and that signal is going to go through a circuit that's going to provide some sort of resistance to ground. Okay, so that resistance that our circuit presents to ground on its output is called output impedance. Okay, now what your output impedance does, so if you're trying to run your signal into another circuit, again, that circuit can just be summed up as one resistor that's going to provide a certain amount of resistance to ground, right? It is fighting against going to ground so it can go through all of the cool stuff the circuit is going to go do for you and then get fed to the output, okay? Now, your output impedance from your tube preamp and the input impedance from the gear you're plugging into create something called a voltage divider. Now, if we go back to the first video, we actually covered voltage dividers because we use voltage dividers in order to create volume knobs, right? So you could look at this kind of like a potentiometer with your guitar signal coming in here, the wiper of your potentiometer being here, and your guitar signal coming out of here, this being the output of your guitar signal, okay? And the bottom part of that pot goes to ground. So if the wiper is in the middle, what happens is 50% of the resistance is here, 50% of the resistance is here, and you lose 50% of your signal, okay? Let's say the wiper is up here, right? And you have 90% of the resistance on the bottom and 10% of the resistance on top. You only lose 10% of your signal. So if we think about this resistor here as the output impedance of our tube preamp, okay? And we think about this resistor here as the input impedance of our mixer, we want to make this output impedance as small as possible, right? We want this wiper to be as close to 100% on the volume dial as we possibly can. We want this resistor that our signal is going to have to go through to be as small as possible, okay? So we want to make the output impedance of our tube preamp as small as possible compared to the input impedance of our mixing desk. Now, we need to figure out a couple of things, okay? Now, what I'm going to do is give you a tool to figure out what that signal loss is going to be. And I'll also give you a tool to figure out what's going to be the impedance to ground for your mic input on your mixing desk. And what's also going to be the output impedance or the impedance to ground that the output of your tube preamp presents. Now, for that, there's a calculator, which I love. The calculator on the calculators on ampbooks.com are really the GOAT for real. Like, I use them all the time and they're really helpful. If you need help like with the nitty-gritty math on calculating output impedance and input impedance, I can help you with that. But this is a really good shorthand just to kind of get your hands around the problem. So if we take a look at a 5E3 schematic, okay, the output of the 5E3 schematic is coming from this tube stage, and we're just going to take a look at this point right here. What kind of output impedance does this represent? We have a plate resistor that's 220K. We also have a cathode cathode resistor that's 1.5K, and we have a cathode bypass capacitor that is pretty much fully bypassing this cathode this cathode resistor. What that allows us to do is be able to get the maximum gain out of the stage for our AC signal. Okay, so what the calculator is going to ask you is exactly those questions. So I have a 220K plate resistor. I'm going to put that in here, 220K. It says, what value is your cathode resistor? 1.5K. Now, it's going to ask, is it bypassed by a capacitor? Yes, it is. When I press recalculate, what it tells me is that the output impedance of my tube preamplifier is 48.67 kilo ohms. Okay, so what we're going to do is we're going to come here. Okay, I'm going to erase this because R1 is not that value. It's the value we got here. It's 48.67K. Okay, so this is going to be 48.67K. Okay, now I have the I have a pretty small mixer. My mixer is the Yamaha MG06, and what I'm gonna do is, I'm gonna oh, I have to write this all over again. Blech. But I'll make that happen. Give me 1 second. So this is 48.6K. Okay, so we have 48.6K. I am going to look up the input impedance for my mixer that I want to connect my gear to. So I'm going to go here, and I am going to say for MG06 mixer, I'm going to say, what is the input impedance for a mic input? Because when we run an XLR out, we're typically going to run that into a mic input in a mixer. So I'm going to put this in here. Okay, and I'm going to scroll down. It's going to bring me to the specs for their mixing consoles, and we're going to find that information quickly. Okay, so it says for the mic inputs, the load impedance or the input impedance is going to be 3K. Okay, so what we're going to put down here for our R2 is 3K. So the formula for signal loss is we're going to take our R1, okay, which is 48.6K. Let's round that up to 49. Okay, and then we're going to divide that by R1 plus R2, which is going to be 49 plus 3, right? So 49 plus 3 is going to give us what? Is going to give us 52. Okay, so let's go into the calculator and go ahead and calculate that. So 49 over 52 is going to give us the percentage of loss that we're going to have when we connect this device to our mixing desk. We're going to lose 94% of our signal because the output impedance from our tube preamp is so high. Okay, now there are ways that we can go about lowering the output impedance of our tube preamp, and one of the ways we can go about doing that is with something called a line matching transformer. Okay, its whole purpose is to allow you to take the output of a device and put it into the input into an input device that needs a different impedance in order for you to maintain your signal integrity. Okay, now there are a number of manufacturers that make really good line matching transformers. So Edcore is a manufacturer that makes really good line matching transformers. And they have one that's made especially for the plates of outputs from the plates of tubes, preamp tubes. So what they will do is they will list their transformers in terms of winding ratios. Okay, so I'll give you the math that will tell you how to calculate what your impedance is going to be once you run through one of these transformers. Okay, so for instance, this transformer has a 8.2 to 1 winding ratio, which means if you have an output impedance that is 10K, it's going to cut that output impedance down to 150 ohms, which is awesome. But how do we figure that out for our specific case, right? So if we took a look at our specific case, we have an output impedance of almost 50K, right? So how do we do the math to figure out how much this transformer is going to knock down our output impedance by? Okay, so what we do is we have to divide the output impedance by the square of this ratio. Okay, so what we're going to do, we'll take our calculator and we'll say 8.2 squared, so that's 67.24. So what we're going to do is we're going to take 50,000, or we'll do 40, what is it, 49.5 thousand, 49, and we're going to divide this by put this in parentheses because I already forgot the number, 8.2 squared, and we'll finish the parentheses. Okay, oops, flipped back. Okay, now if we use that transformer, it is going to cut our output impedance down from 49K to 736 ohms. Okay, so now the way we can, if we buy this transformer, okay, we can change our equation, right? Because R1, rather than being 48.6K, right, now R1 becomes 736, okay? And we're going to take 736, we add that to 3K, so that's 3,736, right? So if I divide this by this, it's going to give us the percentage of our signal loss. Okay, so we're going to have 736 divided by 3,736. Okay. Okay, so now we're losing 20% of our signal. Okay, which is far more acceptable. So typically, in a really good measure of signal loss is if you lose maybe 10%. Okay, so we are really getting there. Okay, so this particular transformer will get us to maintaining about 80% of our original signal. Okay, so that and this is just the transformer. If you think about it, our preamp, we have it going through a gain stage as well, right? So the gain stage is going to help us offset some of that signal loss. Now, if that amount of signal loss is unacceptable to you, what you can do is you can pick a transformer that has a higher ratio. Okay, so this one has a 1:10 ratio, right? So again, you will have to divide by the winding ratio squared, right? So let's go back here. So if we have 49,000, right? 10 squared is 100, so we divide this by 100. Okay. Now this transformer is going to get our output impedance down to 490 ohms, which is great. So why is it great? So we said 490 ohms, right? And we divide that by 3,490. As we said, we're trying to get to we're trying to maintain 90% of our signal. Okay, so we don't want a number. We're trying to aim for a number that is 10% or lower, right? Let's go back to the calculator. 490. We want 490 divided by 3,490. Okay, we are getting there. So we are only losing 15% of our signal. We're at 85%. They have another transformer that will get you even lower output impedance. They have one with an 11.49 ratio. Okay, so as you can see, you can keep going. There are other strategies that you can use in order to lower the output impedance of your tube preamp. One of them is called the cathode follower, using a cathode follower stage, which is a little bit beyond the scope of what we have going on right here. But as you can see, this is the way that you can use to make sure you preserve your signal integrity going into the front of that desk. The other thing that this transformer does for you is one of the ways that XLR cuts down on noise is that it acts almost like a humbucking pickup. Okay, as I said before, whenever you run your signal through a transformer that is center tapped, as it is right here, one end is going to have an original copy of your signal. The other end is going to have a phase shifted copy of your signal. In an XLR jack or a balanced connection, what happens is those signals get summed together and the noise gets canceled out. Okay, so that's how XLRs are able to have long signal runs without imparting noise into your signal. Okay, so this transformer, since it has a center tap on the other end, it allows you to feed the XLR jack. It needs that phase shifted copy of the signal in order to combat the noise that you would get over a long signal run. So this is pretty much it for the series. I appreciate y'all rocking with me, man. I know it takes a little while to really practice this stuff and get it under your belt, but I just encourage you to try it out. I think now is one of the best times that we have. We have a lot of access to folks that manufacture these parts, be they the XLR jacks, the transformers that I talked about. Amplifiedparts.com is a great place to go. Mauser.com is a great place to go. And there are lots of resources online. So take care, y'all. As I mentioned before, we do this for the culture, and I want more of y'all out here doing this. If you need any help with your builds, feel free to hit me up on Threads or IG. Peace.